Hi, welcome to another episode of PitchBitch TV. My name is Alex and I will review for you today the DJI Innovations 550 Hexacopter. Actually, it's the almost ready to fly kit, and that means it comes with 6 motors, 6 brushless speed controllers and of course the frame. The only thing that is missing is the multi-rotor control unit. As the Germans among you may know, I reviewed already the Wookong M multi-rotor control system in combination with a GAUI 500X Quad. The test results were very satisfying and therefore I decided to give DJI's Hexacopter kit a try. It's a brand new hot release. I've just bought this one a few days ago and FedEx delivered it today. So when you are thinking about getting a Hexacopter, you may have noticed that there are currently not many affordable kit solutions available on the market. You may be familiar with brands like Skyjib or Sinister if you are a professional, but these are usually off limits for us hobby guys because they are simply too expensive. For example, a Skyjib 6 frame starts at around 1,600 euro. Of course, there are cheaper solutions. For example, microcopter hexaframes that starts at around 150 euros. The price usually depends on the material and the complexity and the stiffness of the frame. In my humble opinion, a lot of the frames are simply overpriced, especially in the professional fight. Same goes for gimbals. Well, now DJI seems to offer a very interesting kit package to people that are interested in aerial photography and aerial filming. While you can do aerial filming at ease with a powerful quadrocopter, for example a GAUI 500X or a DJI 450 stock kit, a Hexacopter offers more lifting power and there's much more space for your equipment. If you have never flown before a Hexacopter or any multi-rotor system, well, you probably should start with a quadrocopter. Now, you may have heard that DJI also announced the release of a professional hex kit called S800 and an own gimbal solution. When this episode is being published, it is possible that the S800 and the gimbal are both available, so you may want to check out these as an option too. Today I'm going to focus on the 550 because no matter what happens, it will be cheaper than the S800, and while it still seems to offer good quality and some very interesting options. So first of all, in this episode I will unbox the 550 RF kit and show you the components, and secondly I will guide you to the whole building process, and last but not least I will show you how to set up the 550 with a Wookong M or a NAZA unit. As I said earlier, the market offers a wide variety of multi-rotor control systems. However, to be honest, there are not many solutions that are easy to set up and tune. You usually have to do a lot of researching and it's kind of playing like a puzzle. That's where the Wookong M and the NAZA units step in. They offer an awesome stability plus a lot of interesting flight options, especially when it comes to autopiloting, while they are still pretty simple to set up. At the moment you will get a NAZA for about, well, 200 euro I would say, and the Wookong M for around 850. The main difference between the systems is that the Wookong M offers GPS support and more control options, but more about that later. So as a beginner you may want to start with the NAZA. Anyway, let's start and have a look inside the package to see what's inside.
DJI's almost ready to fly kit is currently available for around 320 euro in Europe's webshop. So what's inside? The kit contains 2 red front arms and 4 arms for the back and sides. Then you get 6 30A opto brushless speed controllers, 1 top and 1 bottom board, plus M2.5 and M3 screws. Furthermore, there are 6 small 920 kV brushless motors, fastening tape, and 8 8-inch propellers and 8 10-inch propellers. The lower board handles the power distribution, which is a very nice feature. The solder spots to which you have to solder the speed controllers are clearly labeled with plus and minus, so you can't mix the poles up. The arms are made of very strong and stiff hard plastic material. As you can see, there are quality pre-drilled screw holes. I've moderately crashed on purpose a few times and I wasn't able to break the arms. Next we've got the 920 kV brushless motor. It is suitable for 3 or 4S lipos, but you shouldn't use DJI's 10-inch stock propellers with a 4S lipo, otherwise you risk an overheating malfunction or flyaway. DJI's motors and propellers share a special form. Shaft and hose are not round, so you have to be careful if you want to fly with other propellers than DJI's. Let's have a look at the 30 amp Opto speed controller. The idea behind Opto is that there is no direct electrical connection between the receiver and the business end of the controller, which means less electrical interferences. It also means there is no BEC, but that won't be a problem if you use a Wookong M or a NAZA on your 550 Hexacopter. This brings me to DJI's multi-rotor control system Wookong M. It's a multi-rotor system which is able to control different multi-rotor setups, so you are not stuck with a specific motor mixing. It features 3 different flight modes. These are manual, attitude and attitude plus GPS flying. Furthermore, you can trigger a failsafe with a hover or return to home option. It also offers automatic gimbal control plus a 2-layer voltage protection for your safety. All features can be easily accessed with the Wookong M software assistant. But let's have a closer look at the contents of the box. On the left side you can see the PMU followed by an XT60 plugged power cable adapter, 3 different ports to hold the GPS compass module, 10 patch cables and an USB cable in order to access the main control unit with the software assistant. Below that small box is the real interesting stuff hidden. First the IMU, followed by an external LED, the main control unit and the GPS compass unit. On the left side of the main controller, which is basically the brain of the Wookong M, is a USB 3 port, then we have aileron, elevator and throttle and rudder ports. The U port controls the different flight modes, X1 serves the voltage monitor, X2 the intelligent orientation control, and X3 is meant to control the gimbal pitch. On the other side you can see the motor ports that will be connected with the speed controllers. Please keep in mind that DJI is counting the motors counterclockwise. Right beside these motor ports there are ports for the IMU and PMU. F1 and F2 share 2 functions. You can either use these ports for an octocopter motor mixing, or you can use these ports with 2 servos in order to control a gimbal. Let's move on to the inertial measurement unit, also known as IMU. It contains a 3-axis gyro along with a barometer for control of the altitude. You can place the IMU with an arrow on top of it pointing towards the front, back, right or left. The GPS unit also holds the compass, senses the direction of your multi-rotor system. GPS can only locate the position but not the pointing direction of your nose. You should keep this unit at least 10 centimeters away from the motors and the red arrow has to point straight forward. The external LED is a really nice bonus. It's extremely powerful and the different colors indicate the different states of the system. Even in bright daylight you can easily see the LED flashes. The PMU manages 2 to 6S LiPos. It also features a voltage sensor that is connected with X1 of the main controller in order to monitor the LiPo state. Now, before we move on to the NAZA, keep in mind that you can only access the Wookong main controller with the software assistant if you power up the Wookong system. Anyway, on to NAZA, the so-called prince of multi-rotor control systems. My guess is Wookong must be king then. NAZA is currently available for around €200 at Europe's webshops. In the middle you can see the main controller, right besides it the versatile unit that also contains a voltage sensor. We've also got 8 3-pin patch cables, a USB cable and 3M sticky gyro pads. So let's have a closer look at the main controller that also contains a 3-axis accelerometer and gyro plus a barometer. It's just a bit smaller than the Wookong main controller, but the layout is nearly the same. You can see the aileron, elevator, throttle and rudder ports on the left side, followed by the flight mode control U port. Now be careful, because X1 is not used for the voltage sensor like on the Wookong. That would be X3 instead. X1 is used for the gimbal pitch control, X2 for the gain control. The VU is plugged into the LED port of the controller. On the other side of the controller are the motor ports. The layout doesn't differ at all at this point from the Wookong. F1 and F2 can either be used for an octocopter motor mixing or for the control of 2 gimbal servos. The versatile unit has 2 loose ends that can be soldered to the F550 button board or plug. It can handle, like the Wookong PMU, from 2S up to 6S LiPos. Its LED indicates the system status. So much for the unboxing. Let's move on to the build report of the 550.
Okay guys, as you can see, I've unpacked the box and we have to do some building. First of all, let me show you the tools that are necessary for the build. First, you will need a hex screwdriver 2.5. There are M2 and M3 screws included within the kit. Don't forget thread lock. Secondly, you will need a soldering tool and soldering iron in order to solder the controllers and battery supply to the bottom board, which is actually this one. You also need a pair of wires and a wire cutter. The wires will be the base connection for the RC battery supply. I will use two 4mm bullets as battery connector. Oh, well, let's not forget the cable ties, and I think that's about it. The whole building procedure is pretty straightforward, but you may want to check out the manual from time to time just to be sure. The manual is not included in the kit. You have to download it from DJI's webpage. It's a 10-page long document, I think at the moment in version 1.0, and it features good pictures and descriptions. The good thing about the almost ready to fly kit is that it's basically built plug and play. If you are using the included DJI 30 amp opto speed controllers with the Wookong M or NAZA control unit, you neither have to calibrate the travel range nor do you have to do any other setup with the controllers. So here you can see the lower and the upper central plates that feature an electronic board. That's a very cool feature because that means less cables and more space for your equipment. The lower board is designed as a power distribution board. The upper board will hold your battery and some equipment, for example the GPS module of the Wookong M. Before we start, let me show you the F450 boards in comparison. That may be interesting for those who are thinking about an upgrade. Actually, the 450 quad and the 550 hex share the exact same arms, motors and speed controllers. Even the propellers in the kit are the same. Therefore, if you want to upgrade, you just need to buy two boards, two more arms, motors and speed controllers and props, and you are ready to go. As you can see, the hex offers more space. So let's start with the bottom board, which is this one. Step number one is to solder the speed controllers to the power distribution board. It's important that you use the right poles. Red is plus and black is minus. Well, let's get this done. Yay, I have finished soldering. I really don't like that part, nevertheless I'm finished. And if you have correctly soldered your speed controllers and the RC battery cables to the power circuit of your bottom plate, the whole thing should come close to this. It's important that you solder the red cable to the plus pole and the black cable to the minus pole. You should pull on the cables just to make sure that there is no loose end. As you can see, I've soldered two pairs of cables to the battery connection. One pair with 4mm bullet connectors and one pair with a DNT plug connector. If you want to set up your hex with a NAZA, you would normally solder the open ends of the voltage sensor to the battery connection. That would look like that. Let me show you. Yeah, that's correct. As I'm going to check out the Wookong M and the NAZA, I'm using the second pair with a plug for an easy exchange of the sensors. I can plug in the PMU voltage sensor of the Wookong M like that. I'll show you. And that's the PMU. So next step will be the placement of the multi-rotor control system. In my case, the Wookong M and NAZA will follow later on. Before you assemble the frame with the arms and screws and the upper plate, you should make a decision which parts of the multi-rotor control system you want to locate on the bottom board. With the NAZA it's simple. You basically just have the NAZA main controller unit and the voltage sensor. However, the Wookong M uses several modules. Especially the placement of the IMU is important. The printed side must face you. However, it doesn't matter in which direction the arrow on the printed side is pointing. As you can tell the Wookong M with the software assistant into which direction the arrow is pointing. Important point, you have to place the IMU parallel to the axis. It doesn't matter where you put the main controller. It can be placed anywhere, but you should keep in mind that you have to connect the receiver patch cables and the speed controllers to it. So best is to plan a layout and fix it later with glue tape. Let's start assembling the frame. Okay, unpack the arms and place them like this. Lead the cables of the controllers through the bridge of the arms at the end. 2 red arms for the front, 4 white arms for the back side. We will use the M2.5 screws to fix the arms to the bottom board. As metal screw goes into metal, please use thread lock to tighten it up. So let's get this done. So the bottom board is connected now to the arms. Before we turn the whole frame over in order to install the top board, let's tie the speed controllers to the arms with cable ties. And now we flip the whole thing over in order to install the top plate. Now I will use the rest of the M2.5 screws with thread lock in order to connect the top board with the upper side of the arms. So this was the last screw, and we are ready for the next step. Push it a bit, it shouldn't bend at all, so it's fine. It's motor time. Please use the M3 screws in order to screw and fix the motors to the arms. 4 screws are needed for each arm. So I'm done with attaching the motors to the arms. I did do one stupid mistake, as you may have noticed. I should have attached the motors before I fixed the arms to the bottom and upper plate, because that would have made it easier to attach the motors and put the screws into the motors, so I had to turn it over all the time. Anyway, now next step is coming up, and this will be connecting the motors to the brushless controllers and to check if the motors turn into the right direction, and we need to set up the transmitter for that. Okay, as you can see, all the optocontrollers are connected to the motors. It doesn't matter where you put the 3 cables in, because it's a brushless motor. So if we notice later on that one of the motors is turning into the wrong direction, you simply have to switch one of the cables, so it doesn't matter now where we put them in. For me, the next step will be to set up the Wookong M and the transmitter. I'm using a Spektrum receiver, 8 channels, with DSM-X and a Spektrum DX8 transmitter. You guys can first check the motors if they are turning into the right direction. I will skip this because it's no problem to simply switch one of the cables if you notice later on that one of the motors is turning into the wrong direction. Please keep in mind that DJI is counting the motors anti-clockwise. That means this is motor 1, motor 2, motor 3, etc. While, for example, a F550 quad would be clockwise counted, motor 1, motor 2, motor 3, etc. So that's important if you start connecting the motors or the controllers to the Wookong M or the NAZA unit.
Surprise, surprise, time warp. As you can see, I've finished the build and the electronics. So what did I do? I've bound the 8-channel Spektrum receiver with the Spektrum DX8 transmitter. On the DX8 I've procced a new helicopter model. If you also want to proc the Hex as an helicopter model, use as swash type 1 server normal in the system setup. Also disable all switches in the system setup. You configure them later on in the model setup. If you use another transmitter, keep in mind that you need at least 5 channels in order to control the Wookong or the NAZA. Ideally your transmitter features 7 or 8 channels and the receiver of course. I have installed all the other electronics of the Wookong on the bottom board, which would be the IMU, the main controller and the PMU plus voltage monitor, which is on the other side of the bottom board. You should place the IMU in the middle of the bottom board. That gives you the best chance to avoid any vibrations. Same goes for the NAZA, as its main controller also contains the gyro system. You should use some special gyro double-sided tape when you place the IMU or the NAZA main controller on the board. Both have a printed side. This side has to face you. The pointing direction of the arrow on the IMU will be entered later in the software assistant. The NAZA should point with the motor output ports towards the front of your Hex. As I told you before, it doesn't matter where you put it, but you should go for the center of the bottom board just to be sure to avoid any vibration problems. It's basically the same place where I put the IMU of the Wookong M. If you are not using the 630M stock electronic speed controllers, you have to calibrate your ESCs one by one through the receiver. Do this before you connect them to the Wookong or the NAZA. As I'm using the stock speed controllers, I don't have to calibrate them at all. It's basically plug and play. When you do a first test to check if the motors are turning into the correct direction, please do this without the propellers. I did do already a check and 2 of my motors turned into the wrong direction. To fix that, I simply had to switch 2 of the motor cables with each other. Motor 1 has to turn anti-clockwise, motor 2 clockwise, motor 3 anti-clockwise, and so on. Please use the propellers with an R written on them for the clockwise turning motors. If you're going for a 3S setup, you may want to use the 10-inch props included within the kit. Bigger props are able to lift more weight, while smaller props make the Hex more agile and reaction happy. In the kit there are also 8-inch props included. Do not use the stock 10-inch propellers if you are going for a 4S setup. It is very likely that you will damage your motors or speed controllers by overheating them. To arm the motors, you have to make a combination stick command, for example bottom left, otherwise the motors won't start at all. Now let me show you something else. This is a special landing kit and cheap gimbal for the GoPro. Manufacturer of both is the Polish firm Quadframe. You may want to give it a try. This combination, which means landing gear and gimbal and 2 Hyperion DS11 servo, costs about 120 euro in total. Landing gear with gimbal is around 80 euro, the 2 servos about 40 euro. Of course, this cannot compete with systems like the DJI Z15, but the quality looks fine and it suits my hobby purpose. So actually you don't have to invest high sums of money into a nice looking gimbal for your GoPro. I will show you later more about the configuration. Next will be some flight testing, but before that let me walk you through the software assistant of the Wookong M and the NAZA. Before we start with the software setup of the Wookong M, let me show you how I've connected Spektrum AR8000 receiver with the Wookong M main control unit. I've connected throttle, elevator and rudder channels with the corresponding ports on the main control unit called T, A, E and R. Then I've connected the gear channel with the U port on the main control unit for flight mode control. AUX2 with X2 for intelligent orientation control, AUX3 with X3 for gimbal pitch level control. And last but not least, don't forget to connect the USB cable with your main control unit and your laptop, PC or whatever you are using to access the software and the main control unit. On the NAZA you have to plug the USB cable into the PME voltage sensor. Now, normally bind your transmitter with your receiver. I'm using a Spektrum DX8. You can do this with any other transmitter receiver combination, for example Futaba, but you should have at least 7 channels available for the Wookong M. So let's continue with the Wookong M software setup. Welcome to the software setup of the Wookong M. I will give you a quick overlook over NAZA at the end of this Wookong walkthrough too. So where to start? First of all, you have to download the software and the drivers from DJI's webpage. There are 64 and 32-bit drivers for Windows XP Service Pack 3 or Windows 7. Installation worked nicely, I didn't encounter any problems. You can choose between the English and Chinese language installation. My guess is for most of you English will do. After that I've connected the Wookong M with the USB port of my laptop. You have to power your RC system, otherwise the Wookong M won't respond. So let's do this first. The software will automatically check your firmware version and update if necessary. As you can see, I'm using software version 1.2 and it updated to firmware version 5.2. The blue light down here means that there is communication going on between the Wookong M software and the main control unit. The green light means that the system is online and everything seems to be working alright. To save your different setups, which is pretty nice if you use your Wookong on different multi-rotors, you can export or import your settings and always ensure that you push the right button if you are updating, so you save any changes even though the software seems to update automatically all the time. So let's walk through the setup procedure. In the first tab, motor mixing, you have to configure your motor setup according to the type of multi-rotor that you want to fly. In this case, I'm going to fly the F550 Hexacopter as an Hex 5, meaning the front of the hex is pointing X-like. That's, in my opinion, the best choice if you plan on doing some aerial photography or filming like I do. As you can see, the Wookong nearly supports all existing multi-rotor combinations with preset settings. You can, of course, create your own mixing plan by activating the customizing field. Well, I'm using the Hexacopter 5 for now. Now, please pay attention. The mounting configuration is very important. If you do any mistakes here, you might crash immediately. First, you have to tell the Wookong the pointing direction of your IMU. As I showed you earlier, mine is pointing forward. It is also more or less positioned in the center of gravity on my hex. Therefore, I'm leaving every position at 0. If you are not sure about the center of gravity on your multi-rotor, better leave it at 0 and start to make changes after the first test flight if you notice any crazy stuff. The numbers don't have to be 100% correct. The Wookong is, from my experience, forgiving as long as your numbers are not totally off. More important is that you enter the correct numbers in centimeter when you save the position of your GPS compass unit in the Wookong. Let me show you the axis, as people tend to do mistakes at this point with this picture. A negative value on the x-axis most likely means that you have positioned the Wookong M compass unit towards the backside of your hex, a positive value towards the front. From my experiences, even more important than the x-axis is the z-axis, which means basically the position height of your GPS compass unit. As you can see, I currently have a distance of minus 11 cm on the z-axis from my center of gravity to the GPS unit. So a negative value means the GPS unit is positioned above the top board of your F550.
Do not mix that up by entering a positive value. It seems impossible for a F550 that your value could be positive. Keep in mind that any of these numbers change if you change your setup. For example, if you put a gimbal or landing skid under your F550, or if you change the size of your LiPo, it is very likely that also the center of gravity has changed. As I said earlier, the Wookong is forgiving. However, if you do big mistakes here, especially with the IMU pointing direction, you can crash easily. Ensure that your GPS compass unit is pointing straight towards the front. Next is transmitter calibration. This basically works like the calibration of your transmitter with the Phoenix flight simulator that you may know. Please push the start button and then start moving the two sticks towards all edges. If you got it right, these three should be green and the throttle stick should be green at middle stick position. As I'm using a Spektrum AR8000 receiver with a satellite, I'm choosing traditional receiver. And furthermore, you can choose between intelligent and immediate motor cutoff. I'm choosing intelligent. When you activate this feature, the Wookong will turn off motor slowly by itself after landing. As I showed you earlier, I have connected the X2 port of the Wookong M main control unit with AUX2 of the Spektrum receiver. So I'm able to use the intelligent orientation control, which is hiding under autopilot and menu point 4. What is intelligent orientation control? Usually the forward flying direction is the same as the direction of your hex nose. If you use the intelligent orientation control, it doesn't matter where your nose is pointing to. You can do home lock and course lock flying. If you do a course lock, then flying forward is the same as the nose direction that you have recorded earlier. If you do a home lock flying, then the forward direction is the same as the direction from the home point to your F550. So home lock can work as some kind of manual failsafe if you want to get your hex back and you are not sure about the pointing direction because it's too far away, for example. Please consult your manual for this. It would simply blow the size of this video if I would walk you through that whole setup procedure now. DJI detailly explains how this works on 4 pages in the manual. On to X3. X3 controls the gimbal pitch control. I've mapped the AUX3 channel to my knob on the Spektrum DX8, and then AUX3 is connected with the servo patch cable with the X3 port of the Wookong control unit. Now, when I turn the knob on the DX8, you can see the movement here. So this allows me directly to nick the camera, and the automatic gimbal control will always try to hold the camera in the position that I've chosen. Now on to the most important point, the flight mode control. This is why you need at least 5 channels to be able to control a Wookong system. Best is that you have at least 3-point control switch on your transmitter that can be programmed. I've connected the gear port of my AR8000 with X1 of the Wookong. Then I've mapped the gear channel on my DX8 to the gyro 3-point switch. In the gyro menu you can enter 3 different values. The actual numbers for the different flight modes depend on your transmitters and its calibration, so it's very likely that yours are not the same as mine. So if I switch now through the 3 modes, you can see how the Wookong changes the modes. In failsafe mode, the Wookong flies home to the starting location via autopilot and GPS support. Of course, this only works if GPS is available. Manual turns off any autopilot support, even the attitude barometer. In this mode you can do acrobatic flying. Attitude will be most likely your most used feature. It keeps your multi-rotor at the same level, so you just have to care about the direction movement. If you switch to GPS, both attitude and GPS autopilot functions will support you flying, so you can hold your position in the air within 1 or 2 meters, at least if you did set up everything correctly. For the Wookong you really require a 3-position switch, otherwise you won't be able to calibrate the compass. To do this you have to switch from manual over to ATI over to GPS and back like 6 or 10 times very fast. Do this outside. If you are successful you will see a constant blue light on the LED. Then take the hex and turn clockwise until the circle is closed. Then the LED should turn green. Then take the hex vertically and repeat. If you have been successful, then the LED should turn white.
If you see red dots flashing, then you have done something wrong and you have to repeat the procedure. Now please pay attention, because I'm going to show you how to do a setup auto-failsafe with an AR8000 Spektrum receiver. There seems to be a lot of confusion on the forums how to do this, so I'm going to show you. You have to repeat the binding procedure to do this. First, change one of your switch positions to the value that triggers the failsafe on the Wookong. In the menu tab Autopilot, you can tell the Wookong under Enhanced Failsafe Methods what to do. Once failsafe is triggered, I choose Go Home and Landing. Now turn off the RC power and your transmitter. When you turn it off, ensure that you have the 3-position switch to the position that triggered failsafe. Put a bind plug into your receiver and turn back on the RC power. As you can see, the receiver is blinking. Now remove the bind plug. Now turn on your Spektrum transmitter while pushing the bind button. Ensure that you have throttle above at least 10%. After binding is complete, the receiver has now stored all current signals. So if you lose signal while flying, or you simply turn off your transmitter, the Wookong switches automatically to failsafe because it gets the same signal by receiver that you had mapped to the position of your switch. Anyway, on with the software setup and the autopilot basic parameters. I'm sticking with the preset settings. I won't change anything for the Maiden-Flight. If I were you, I would do the same. You can change on later any values if you think that they need adjustment. As I showed you earlier, I'm using a small GoPro gimbal and a landing skid by Quadframe. Therefore, I've activated in the Gimbal tab the gimbal control. The center position that I've chosen for the pitch and roll servos is -200, -200. I can adjust the pitch nick level with my DX8 knob, as aux3 is mapped to X3. The Wookong will try to hold this level even when the F550 is leaning forward and back in the sky. And I just had to reverse the pitch servo. Everything else is default. The Wookong also features a voltage monitor for your LiPo safety. Be careful about the values that you enter. If you're using different LiPos, like I do, you may have to recalibrate often. So for the Maiden-Flight, I will be turning this feature off. If you're using the voltage monitor, you have 2 levels of protection. Level 1 gives you LED warning or go home and land as choice. Level 2 just descending. Be careful about this one, it can go down quick. And well, that's about it. We are done with the Wookong M software walkthrough. Let's move on. Before we switch over to flight testing with the Wookong, let me give you a quick overview over the NAZA software. Its graphical interface doesn't look much different than the Wookong one. You just have less features available. Choose your motor preset mixer, for example X6 Hexacopter. Transmitter calibration works basically the same as on the Wookong M. One important note, the voltage sensor goes not into X1 as on the Wookong, but into X3. The U port is also used for flight mode control. The difference is that you don't have GPS support available, however attitude works the same. The binding procedure, especially failsafe, doesn't differ from the Wookong failsafe. In Autopilot you can adjust some values if you want to. Gimbal control also works like on the Wookong, and same goes for the voltage protection. Well, that's about it, so let's move on. Welcome outside for the maiden flight of the DJI F550 Hexacopter. I'm at the RC-Heli Düsseldorf RC Flight Club, and as you can see the weather is pretty shitty. However, there's not much wind and it's calm, so idle conditions for some flight tests. I'm using the Wookong M as multi-rotor control unit, and I've connected 2 Hyperion DS11 servos of my cheap gimbal that I bought with the F1 and F2 ports of the main control unit of the Wookong M.
I'm using a GoPro 1 in a special protection FPV case as onboard camera. So let's check if I'm having any vibrations in the picture and how the F550 is doing in the Maiden-Flight.
Before we take off, let me show you a special FPV GoPro protection case. It's very lightweight and cheap, while it still offers some basic protection for your GoPro. I've bought it at the German web shop iFly. I'm moving the hex a bit around so that you can see how the gimbal is working. It tries to compensate my movement and to hold the camera's position. It's not perfect or lightning fast, but for such a cheap solution I think the whole thing is doing fine. For the Maiden-Flight, I'm using a Turnigy 4S 5800 mAh LiPo. I've bought it at Hobby King and it's very cheap for its size. As I'm doing the voice recording after the flight test, I can tell you that this LiPo lasts for around 8 or 9 minutes, depending on your flight style. I think that's a very good flight time white balance. Anyway, let's power the system up. I will show you the Maiden-Flight from different perspectives. We had several cameras running plus the GoPro on board. When you power on the Multi-Rotor system, don't move the axe for a few secs. The first takeoff should be in attitude mode just to be sure that everything is working correctly. As you can see, it seems that I didn't make any big mistake. The GoPro picture is also looking fine. Please don't push the Hexacopter like I do, it's dangerous. I'm doing this to test and show you the stability of the Wookong. The propellers can seriously injure you. In ATI mode the autopilot tries to hold altitude by itself, however it still drifts in the wind. Now I'm adding autopilot GPS support by moving the gyro switch on my DX8 to position 3. In this mode the autopilot will try to hold the axe on its position as long as I don't command anything else. As you can see, this works nicely. I did push the F550 the same around when later on I had installed NAZA as control system. NAZA basically offers the same stability in attitude mode, it just misses GPS support, so it drifts in the wind as there is no GPS to lock on position. And that's how it looked like on board when I pushed the axe. Now I'm doing a forward flight to check if the compass is off. That would be the case if the hex won't fly straight forward with GPS compass support turned on. If the hex doesn't fly straight forward, recalibrate your compass or check your setup for electromagnetic interferences. In my case, the compass looks good. The gimbal control does its job. This is raw video material. I didn't run the video through D-Shaker in post-production, so I didn't regret the extra investment of 120 euro for the landing gear, a 2-axis GoPro gimbal and 2 DS11 servos. You can see the gimbal working if you keep an eye on the top of the front arms in the onboard picture. Okay, let me gain quickly some altitude. The reaction seems a bit slow, therefore it's likely that I will raise later on the basic gain and attitude gain parameters a little bit. But for a maiden flight it's looking good. Now ground hover testing is upcoming. Again, the Wookong keeps the F550 very stable. You can barely notice the ground effect. That's nice, especially if you want to do some close-up aerial video filming. Before the LiPo is being sucked dry, let's test the failsafe. I'm testing the go home and land failsafe. Now failsafe is on. First the autopilot tries to reach a safety altitude of 20 meters. After reaching 20 meters, the Wookong takes the shortest route to the home location. Once it has reached the home position above ground, it tries to hold it for a few seconds before it starts descending. If you experience the so-called toilet bowl or whirlpool effect in failsafe mode, which means the Wookong flies circles while it auto-descends, please reposition the compass unit and check your setup for electromagnetic interferences. Magnetic interferences can interfere with the compass, especially when the failsafe autopilot is taking over. As you can see, the autopilot descends nicely. In conclusion, I'm very satisfied with the F550 Wookong M combination. Also, the NAZA did do a fine job later on. With the F550 you get an awesome top quality Hexacopter kit for a very reasonable price. The Wookong M is a nearly perfect multi-rotor control system, and its little brother NAZA is probably the best choice for the beginner. If you plan on doing some aerial photography, filming or first person video flying, this combination can be the perfect kit for you. Give it a try, I'm sure you won't regret it.